Hello everyone, my name is Arvind Krishnan and I'm a simulation specialist working from the Dallas office. In this video, we're going to look at some of the functionalities in SOLIDWORKS flow simulation, namely fluid mixing, transient analysis, and optimization. Mixing of fluids is a very important phenomenon that needs to be accurately modeled to understand the behavior of the different fluids involved and also understand at what rate this mixing happens. SOLIDWORKS flow simulation gives you the capabilities of mixing different fluids as long as they're in the same state. Flow simulation in general allows you to use non-Newtonian fluids, gases, real gases, liquids, and when you want to do fluid mixing, you just need to make sure that the fluids getting mixed are in the same state. As long as that's done, the fluid mixing can take place and an analysis can be done. So here we're going to start out with this cylinder filled with helium, and we pump air from one side and look at how the volume fraction changes as a function of time. Real quick, using the wizard to get the analysis started, we're going to give this a name, some default units that are used. We definitely want to make sure that this is a time-dependent analysis and it's going to be internal. We're going to run the study for 30 seconds and save the results every 1 second. Here are the different types of fluids that can be used in an analysis. Once again, when trying to do fluid mixing, you want to make sure that both of them are the same type of fluid. So we're going to go to gases and make sure that air and helium are selected. Once we do that, we're also going to make sure that the entire cylinder is initially filled with helium. This sets up the majority of the analysis. I have already created a model which we're going to use. So once you've set up the majority of the analysis, we need to also make sure that there's an inlet of air from one side. So here's a boundary condition defining the substance concentration of the fluid coming in from one direction, which is just air. Once we do that, we can specify environmental boundary conditions on the other side and set up a bunch of goals that the solver is going to use to reach convergence as it solves for the fluid behavior inside the cylinder. We've already loaded up some results. So let's go ahead and look at a cut plot. So this cut plot is at the end of time and it shows us the volume fraction of air. A new functionality in 2017 lets us see how this volume fraction changes as a function of time. Once loaded, you can use the bar to see how that fluid fraction changed as a function of time. We can take this analysis one step further and also do an optimization. So I'm going to go ahead and turn on the optimization tool. Here we can alter the inlet volumetric flow rate and specify a range of minimum and maximum values for that inlet such that my goal, which is the volume fraction of air, reaches 95% at the end of the 30-second mark. Once we set this up, we can select the scenario tab and run the optimization analysis. It's going to look at multiple design points and compare the volume fraction, and based on how the volume fraction changes, it's going to converge on a specific volumetric flow rate for which the goal that we provided is within an acceptable range. Once again, we spoke about fluid mixing, transient analysis, and optimization of a parameter using SOLIDWORKS flow simulation. Once again, this is Arvind Krishnan from Go Engineer. Thank you.